Software is a set of instructions. These instructions tell a computer what to do. Think of it like a recipe for a machine. The computer follows these steps precisely. Without software, our hardware is just an empty shell. It cannot perform any useful tasks on its own. Software brings these powerful machines to life. It allows them to process information, display graphics, and communicate with other devices. This transformation is fundamental to their utility in our daily lives, making them indispensable tools for a myriad of functions. You interact with software constantly. Your smartphone runs on software. The apps you use, like social media or banking, are software. Cars now have complex software systems. They manage the engine, brakes, and entertainment. Even your microwave likely has a small piece of software controlling its functions. This ubiquity means software impacts nearly every aspect of modern existence. From simple tasks to complex operations, software is the invisible force guiding the technology we rely upon every single day, often without us even realizing its presence. Software development is the process of creating the software. It is a craft, much like building a house. It involves careful design, skilled construction, and thorough checking. Developers are the architects and builders of the digital world. They use specialized tools and languages to write these instructions. Their work requires creativity, logic, and attention to detail. The goal is to produce software that is reliable, efficient, and easy to use. This process is both an art and a science, demanding a blend of technical proficiency and innovative thinking. This guide will walk you through the world of software development. We will explore how software is made, from the initial idea to the final product. We will discuss the tools developers use. We will also look at the skills needed to become a software developer. Understanding this field is important in our tech-driven society. Whether you want to become a developer or simply understand technology better, this knowledge is valuable. It empowers you to appreciate the complexity and ingenuity behind the digital tools shaping our future. The planning phase is the first crucial step. It is like creating a detailed blueprint before building a house. Without good planning, a software project can easily fail. It might go over budget, miss deadlines, or not meet user needs. Careful planning sets the foundation for success. It helps the team understand the project's goals clearly. It also helps manage expectations from everyone involved. This initial phase is critical. Skipping or rushing it often leads to significant problems later in the development cycle, proving more costly in the long run. Gathering requirements is a key part of planning. This means understanding what the software should do. Developers talk to clients or potential users. They ask questions to uncover all the necessary features. For example, if building an online store, requirements might include user registration, product listings, and a shopping cart. Documenting these requirements clearly is essential. This ensures everyone on the team has the same understanding of the project's objectives. Misunderstood requirements are a common source of project failure, so clarity here is paramount. Defining the scope comes next. Scope outlines the boundaries of the project. It specifies exactly what will be built and what will not. This helps prevent scope creep, where new features are constantly added. Adding unplanned features can delay the project and increase costs. A well-defined scope acts as a contract. It keeps the project focused and manageable. For instance, for a simple weather app, the scope might include current weather display, but exclude historical data analysis for the first version. This focused approach ensures timely delivery of core functionality. Finally, planning involves creating a roadmap. This roadmap includes timelines and milestones. Milestones are specific goals to be achieved by certain dates. This helps track progress and keep the project on schedule. The roadmap might break the project into smaller, manageable tasks. For example, developing the user login feature could be one milestone. Having a clear plan allows the team to anticipate potential roadblocks. It also helps in allocating resources effectively, ensuring that the right people are working on the right tasks at the right time for optimal efficiency. Coding is where the actual software is built. It is the process of writing instructions in a programming language. These instructions tell the computer how to perform the tasks identified during planning. Think of a programmer as a translator. They translate human ideas and requirements into a language the computer understands. This translation requires precision and logical thinking. Every line of code contributes to the software's functionality. It is a meticulous process that transforms abstract concepts into tangible digital products, requiring both creativity and discipline. Choosing the right programming language is important. Different languages are suited for different types of projects. Some are good for web development, others for mobile apps, and still others for data science. For example, JavaScript is common for websites. Swift or Kotlin are often used for mobile apps. Python is popular for data analysis and machine learning. The choice depends on the project's needs, the team's expertise, and the platform the software will run on. Selecting an appropriate language can significantly impact development speed and software performance. Writing clean code is a hallmark of a professional developer. Clean code is easy to read, understand, and maintain. It is well organized and follows consistent conventions. Another developer should be able to pick up the code and understand it without much difficulty. This is crucial because software often needs to be updated or fixed later. Messy code, sometimes called spaghetti code, is hard to work with. It can lead to more bugs and make future development slow and painful. Therefore, developers strive for clarity and simplicity in their code. Version control systems, like Git, are essential tools in coding. They help manage changes to the codebase over time. Imagine multiple developers working on the same project. Version control allows them to work on different parts simultaneously without overwriting each other's work. It also keeps a history of all changes. If a new change introduces a bug, developers can easily revert to a previous working version. This system acts as a safety net. It greatly improves collaboration and reduces the risk of losing work, making it indispensable for modern software development teams. Testing is a vital stage in software development. Its main purpose is to find and fix errors, often called bugs. Releasing software with many bugs can frustrate users. It can also damage a company's reputation. Thorough testing ensures the software works as expected. It verifies that all features meet the specified requirements. Quality software is reliable, stable, and performs well under various conditions. This stage is not just about finding faults, it is about building confidence in the product before it reaches the end users. There are several types of testing. Unit testing focuses on individual components or modules of the software. Developers often write these tests themselves. Integration testing checks if different parts of the software work together correctly. For example, ensuring the user registration module correctly communicates with the database module. System testing evaluates the entire system against the original requirements. User acceptance testing, UAT, involves actual users testing the software to see if it meets their needs in real-world scenarios. Each type of testing plays a role in ensuring overall quality. The role of testers or quality assurance QA engineers is critical. They are experts at finding weaknesses in software. Testers design test cases based on the software's requirements. They try to break the software by using it in unexpected ways. They meticulously document any bugs they find, providing developers with the information needed to fix them. A good tester thinks like an end user, but with a more critical eye. Their goal is to ensure the software is robust and user-friendly. They are the guardians of quality throughout the development lifecycle. Testing is often an iterative process. This means testing, fixing bugs, and then testing again. When a bug is found and fixed, the software needs to be retested. This is called regression testing. It ensures that the fix did not introduce new problems elsewhere in the system. This cycle continues until the software reaches a satisfactory level of quality. For example, in an agile development environment, testing happens continuously alongside coding in short cycles. This approach helps catch issues early and often, leading to a more stable final product. Section 5. Going live. The deployment process explained. Deployment is the stage where the software is made available to users. After thorough planning, coding, and testing, it is time to release the product. This could mean installing it on users' computers, publishing it on an app store, or launching a website. The deployment process needs to be carefully managed. A smooth deployment ensures a positive first impression for users. Any hitches during this phase can undermine all the hard work done previously. It is the culmination of the development effort, marking the transition from a project to a live service or product. Several steps are involved in deploying software. First, there is preparation. This includes finalizing the code, preparing servers or infrastructure, and creating documentation. Then comes the actual release. This might involve uploading files, configuring databases, and performing final checks. After the software is live, monitoring is crucial. The team watches for any unexpected issues or errors. For example, a web application deployment might involve updating files on web servers and then monitoring server load and error logs closely. These careful steps help ensure stability. Software development teams often use different environments. A development environment is where programmers write and test code locally. A staging environment is a replica of the production environment. It is used for final testing before going live. The production environment is where the actual users interact with the software. Using separate environments helps catch problems before they affect users. For instance, a new feature for an e-commerce site would be tested rigorously in staging to ensure it doesn't break the payment gateway before it's pushed to the live production site. Continuous integration and continuous deployment, or CI/CD, are modern practices. CI means developers regularly merge their code changes into a central repository. Automated builds and tests are then run. CD means automatically deploying the software to production after it passes all tests. CI/CD pipelines make the deployment process faster and more reliable. They reduce the chances of human error. For many tech companies like Netflix or Amazon, CI/CD allows them to release updates multiple times a day, ensuring rapid feature delivery and bug fixes. Section 6. Tools of the Trade. A look at popular programming languages. Programming languages are the fundamental tools for software developers. They provide the syntax and rules for writing instructions that computers can execute. There are hundreds of programming languages, each with its own strengths and weaknesses. Choosing the right language depends heavily on the type of project. Factors like performance requirements, platform compatibility, and available developer expertise play a significant role. Understanding the characteristics of major languages is essential for any aspiring or practicing developer. This knowledge allows for informed decisions when starting new projects. Python is a very popular programming language. It is known for its readability and simple syntax. This makes it relatively easy for beginners to learn. Python is incredibly versatile. It is used in web development for building server-side applications. It is also a dominant language in data science, machine learning, and artificial intelligence due to its extensive libraries. Companies like Google and Instagram use Python extensively. Its large community and vast number of available packages make it a powerful tool for a wide range of tasks, from scripting simple automation to building complex systems. Java is another widely used, robust programming language. It was designed with the write once, run anywhere philosophy. This means Java code can run on any device that has a Java Virtual Machine, JVM. This platform independence makes it popular for large-scale enterprise applications. Many large corporations rely on Java for their critical systems. Java is also the primary language for developing native Android mobile applications. Its strong memory management and object-oriented features contribute to its reputation for stability and performance in complex environments. JavaScript is the cornerstone of modern web development. Initially created to make web pages interactive on the client side, in the browser, its role has expanded significantly. With Node.js, JavaScript can now also be used for server-side programming. This means developers can use a single language for both front-end and back-end development, which can simplify the development process. Almost every interactive website you visit, from social media platforms to online news sites, uses JavaScript extensively to create dynamic and responsive user experiences. It is an indispensable skill for web developers. Section 7. The Developer's Toolkit: Essential Skills for Success. Problem solving is the most crucial skill for a software developer. At its core, software development is about solving problems. This could be automating a manual task, processing complex data, or creating an engaging user experience. Developers need to analyze problems, break them down into smaller, manageable parts, and then devise logical solutions. This often involves thinking critically and creatively. For example, when an application crashes, a developer must methodically investigate the cause, like a detective solving a case, to identify and fix the underlying issue. This analytical ability is highly valued. Attention to detail is another vital skill. In programming, even a small mistake, like a misplaced comma or a misspelled variable name, can cause the entire program to fail or behave unexpectedly. Developers must be meticulous in their work. They need to review their code carefully and test it thoroughly. This precision extends beyond just writing code. It also applies to understanding requirements accurately and documenting work clearly. Overlooking a minor detail in the planning phase can lead to significant rework later. This carefulness ensures software quality and reliability. Teamwork and communication are essential, especially in larger projects. Software development is rarely a solo effort. Developers often work in teams, collaborating with other programmers, designers, testers, and project managers. They need to communicate ideas clearly, listen to others, and work together towards a common goal. Good communication helps prevent misunderstandings and ensures everyone is aligned. For instance, daily stand-up meetings in agile teams are designed to facilitate quick communication about progress and any roadblocks, fostering a collaborative environment. Strong interpersonal skills are key. Continuous learning is a fundamental aspect of a software developer's career. Technology changes rapidly. New programming languages, frameworks, and tools emerge constantly. Developers must be committed to lifelong learning to stay relevant and effective. This involves reading articles, taking courses, attending conferences, and experimenting with new technologies. What is considered best practice today might be outdated tomorrow. For example, a web developer who learned HTML and CSS years ago now needs to master modern JavaScript frameworks like React or Angular to build contemporary web applications. This adaptability is crucial. Section 8. Navigating hurdles. Common challenges in software development. One of the most common challenges is changing requirements. Often, during the development process, clients or stakeholders realize they need new features or want existing ones to work differently. This is known as scope creep. While some change is inevitable, uncontrolled scope creep can derail a project. It can lead to missed deadlines, increased costs, and frustrated developers. To manage this, teams use agile methodologies that embrace change in a structured way. Clear initial communication and a formal process for approving changes are also vital. For example, a project manager might assess the impact of a new feature request on the timeline and budget before agreeing to it. Tight deadlines are a persistent source of pressure in software development. Businesses often want to release software quickly to gain a competitive advantage or meet market demands. This can lead to developers working long hours and potentially cutting corners, which might affect quality. Effective project management is key to handling deadlines. This includes realistic estimation of tasks, prioritizing features, and breaking down the project into manageable iterations. For instance, releasing a minimum viable product, MVP, with core features first, and then adding more features in later versions, can help meet initial deadlines without sacrificing essential quality. Bugs and debugging are an inherent part of software development. No matter how skilled the developer, errors will occur. Finding and fixing these bugs, a process called debugging, can be time-consuming and frustrating. Some bugs are simple typos, while others can be complex logical errors hidden deep within the code. Developers use various debugging tools and techniques to isolate and resolve these issues. It requires patience, persistence, and strong analytical skills. Think of debugging a complex system like a patient diagnosis. The symptoms are visible, but finding the root cause requires careful investigation and testing of hypotheses. Keeping up with the ever-evolving technological landscape is a constant challenge. New programming languages, frameworks, libraries, and development tools are released frequently. What was cutting edge a few years ago might be obsolete today. Developers need to dedicate time to continuous learning to stay current with these advancements. This can be difficult to balance with project deadlines and daily work. Companies can support this by providing training opportunities or dedicated learning time. For example, many software engineers attend industry conferences or participate in online courses to learn about emerging trends like cloud computing or artificial intelligence advancements. Section 9. Your journey begins. Tips for aspiring software developers. To start your journey in software development, begin with the fundamentals. Do not rush into complex frameworks or specialized areas immediately. First, understand core programming concepts like variables, data types, control structures, loops and conditionals, and functions. Choose a beginner-friendly language like Python to grasp these basics. A strong foundation will make it much easier to learn more advanced topics and new technologies later on. Many free online resources such as Codecademy or Free Code Camp offer excellent introductory courses. Focus on understanding why things work, not just how to type them. Practice is absolutely key to becoming a proficient developer. Reading books and watching tutorials is helpful, but you truly learn by doing. Start building small projects as soon as you learn the basics. This could be a simple calculator, a to-do list application, or a basic website. These projects will help solidify your understanding and give you practical experience. As you build, you will encounter problems, and solving them is an invaluable part of the learning process. Don't be afraid to make mistakes, they are opportunities to learn. Each project you complete adds to your skills and your portfolio. Join communities and connect with other developers. There are many online forums like Stack Overflow or Reddit communities, for example, RR Learn Programming. Local meetups or coding bootcamps also offer opportunities to network. Learning from others, asking questions, and seeing how experienced developers solve problems can accelerate your growth. Sharing your own projects and getting feedback is also very beneficial. The software development community is generally very supportive. Being part of a community provides motivation and helps you realize you are not alone in facing challenges. Finally, stay persistent and be patient with yourself. Learning software development is a marathon, not a sprint. There will be times when you feel stuck or overwhelmed by the amount of information. This is normal for everyone. Break down complex topics into smaller, more manageable parts. Celebrate small victories along the way. The key is to keep practicing, keep learning, and not give up. With dedication and consistent effort, you can achieve your goal of becoming a software developer. The rewards, both intellectually and professionally, can be immense in this dynamic and impactful field.